Hi, I finally found the time and managed to create extension for Visual Studio Code with which we can now debug code, scripts, VisionPro and Designer relatively comfortably and efficiently. Directly using Visual Studio Code without the need to install and pay for a large Visual Studio. For those of you who don't already know, Visual Studio Code is a free tool from Microsoft. It's great, from writing plain text documents to programming large complex projects in a variety of programming languages. In this video, we'll show you how you can use our VisionPro Debug extension to debug VisionPro and Designer scripts. You can install it easily in the left bar of Visual Studio Code. Click on Extensions tab. You enter MTS. You select the VisionPro Debug extension. Click Install. It is possible that you will still need to manually install the .NET SDK for Visual Studio Code for proper functioning. You can find the download link directly in the README extension. Once we have it installed, we can go debug some script. In Designer, there are two main types of scripts, namely Designer and VisionPro scripts. For example, script block in task, or some scripts in the scripting section, where there is on startup, on shutdown, key scripts, data change scripts, user scripts, also when we receive, send data from external devices, but also events from the graphical interface, such as on click. And everything related to the Designer and scripting in the Designer. Except the expression builder in the graphical interface. That's a different chapter. All these scripts are set up in the same way for debugging, so we will show it on this script block in the tray, where we have some input, which are actually the results from the blob tool. And there is some loop with which we write the results of individual blobs into the log. When I run such a task, an image is loaded, then it runs through the tool block, in which it evaluates the blob tool. And here it throws some error. It shows us that in the parameter index something is there. Simply a problem. To be able to debug the script, we just need to add a little command at the beginning. System debug break. That way, when we compile this script, the designer knows that we want to debug it. And when it hits this line when executing the program, it passes the execution control to debugger. But in order to hand over this control to some debugger, we are going to run it. We activate our extension using a command, which means that here at the top you write the arrow and type VisionPro debug, or you can do the same via Ctrl-Shift-P where it automatically enters this arrow. And now you just confirm with Enter or click on it by mouse. And wait until it throws you such a list of processes that we can now connect to, and we go looking for the designer. When we found our process, we click or enter and wait a while for the debugging to be initiated. Wait for this expression VisionPro debug ready and wait a while for these yellow lines to pass. When it settles down, the debugger is ready. You can see that you have some control here for debugging, some call stack. And simply, when you let go of the task now, you give run all or you give run selected. It automatically throws you on which line the breakpoint was set. That's our system debug break function. It's a bit longer than we have written in the script, because this part is added by the designer where the $ is written. But this is not important. The important thing is that we can now step through this program and watch it as if in slow motion. How its execution takes place using this arrow or step over, F10. We can also execute individual commands and go from line to line like this, exactly how the program should work. In this case the I was assigned 0. Here is to find out if it is less than or equal 30. Then this line is executed in the script and the cycle is repeated. Here again the I is assigned a unit, the condition is checked and the execution is repeated again. In this way, it could take quite a long time to run the whole cycle, so we can use step out, or Shift plus F11, when we jump out of the function. And we can notice that the program, or debugger, caught an exception and it occurred in this line. It says that there was an exception that was not handled in our code. That there is some incorrect argument, index, it must be greater than or equal to 0, but at the same time less than the count, but the count of what? Since we are working with an array of blobs and pulling out according to the index of their area, we have to focus on the field that is large enough as the 30 that we require, the 30 objects we require. We can see it right here in the variables view. Here we have to search through some maybe not very clear or obvious names. But with some intuition, it can be done. We find that unfiltered blobs, then there is a result view and we see here that there are 16 blobs indexed from 0 to 15 and so we ask for a 16th that doesn't exist. This means that we have to somehow treat the cycle so that it does not require elements of the field that do not exist there. So either we will dynamically determine by the size of the array, or we have to make sure that the blob always gives the same number of blobs. If it doesn't, then we don't even have to go to this function if 30 elements are really needed, and so on. Now, when we want to change something, we cannot change it here in the script. Actually we can, but it won't be reflected in Designer. Because this is just code for the debugger visualization and it's not a two-way communication between this script and the Designer's script. Also, when we want to switch, click through to the Designer, the system will not allow us to do so, because this window is managing its process. So we must first run continue process or disconnect. If we continue, the debugger will return the control to the Designer. Now we can switch the window. For us, this script throws an exception, but we work as if nothing happened. The debugger listens to our process and we can step through our program again when we press run. And as you can notice, there is that empty line that I left before, but that's only because when I didn't run compile, Script Designers still shows us the code that was generated before. So when we change it here, we see the change here, but the program does not really see this change and works as if it works with the old program. Demonstration. If I wrote some new lines here and saved this script. Continue. To get to the Designer, I still see in this script what was there before. And when I compile this script and the debugger reboots in the background, and I run the task, so a new script opens with a new generated designation and this script is completely invalid. I can close it and I work again only in this new script, which has now been compiled by the Designer. I'd like to show you more options of the debugger, so I'll go back to the Designer script. I'll copy this multiple times, simulating a larger script. And let's say I'm going to put only to here. I'm going to give some 10 here. This could come to us without any problems and we're going to leave this at 30. Compile, and we're going to wait for the debugger to refresh. Now run the task. And the execution is paused on the first line where the system debug break is. And now we know that this cycle should be fine by now and there was some error with some 16 element. so we don't have to wait for all this to go through all these lines like this. But we can simply put a breakpoint on this line, and when we give continue, the debugger will go through the whole program until it gets to the point that we have indicated. Of course, there can be more of these breakpoints in the program. Now it got to the beginning of this loop when 10 remained inside I variable from the previous cycle. Now it has been set to 0. We can also set a conditional breakpoint. That is, we put some condition there, and let's say we want to stop here when I equals 15. So we give the right click, add conditional breakpoint, and we give that when I is equal to 15. We give a run, and now we have stopped in a step where 15 cycles have passed. Now the 16th cycle begins and we can actually step through. And now it threw us the exception. Of course, it would be ideal to break down the command into multiple lines to see in which line the problem occurred. It is easier to step through the program line by line. But this is just so that you understand that you also have the option to choose a faster paths in the debugging using breakpoints and conditional breakpoints. It may happen that the debugger does not allow you to give a breakpoint here. For example, if I change this script and I want to put a breakpoint here somewhere, you can see that it throws me gray circles here, which means that the debugger is no longer connected to this script. It doesn't know about this script, how it should work, and how to connect it to the program. In this case, I recommend recompiling the script in Designer and set up breakpoints in a new program, in a new script that the debugger throws at you when debugging. So in this script you can set breakpoints again. But as I mentioned at the beginning, we have two main types of scripts, and the second type is VisionPro script, which is used to manage VisionPro toolblocks. Whether the main toolblock, or nested toolblocks, or even Cogtool group. To be able to debug these scripts, we have to switch compilation mode of the script to debug mode. This means that it will not optimize the running of the program and will also generate debug symbols. And we also uncomment this block, or you write down a line like this somewhere, which then allows the debugger to connect. And this means that this line is compiled only when it is switched to debug mode. And it's basically the same as in the system debug break design script, so this is actually the command to hand over the execution control to debugger. So when I put compile, I wait a while for it to refresh in the background. Also, when I close this window, another refresh will also take place. And now when I give run, the program stops in the debugger and I can step through my program again, and I can also see individual variables. Tools, for example. We can see Cogblub tool as it evaluated. Let's see some result. We can see what the results of individual blobs are. Let's see the second blob's results. Area, angle, this is his x, y, center of mass, so this is actually his position. Once you're satisfied with how your program is running and want to stop debugging, all you have to do is disconnect. Of course, if you want to continue again, you run the VisionPro debug command again and connect to the correct instance of the designer. And I also recommend that you don't forget to switch the compilation mode to release and recompile the script to make it as efficient as possible for the final run of the program when you do the deployment. So I hope that this extension will make it a little easier for you to work with VisionPro and Designer in an efficient and enjoyable way. See you in next video.